our experiment that investigates the effect of temperature on the rate of a reaction. So our learning intention is to study the effect of temperature on the rate of a reaction using sodium thiosulfate and hydrochloric acid. So in this video we're going to briefly explore the effect of temperature on the rate of reaction using sodium thiosulfate and hydrochloric acid. So this diagram is a very clear way to show you how the results of our experiment will differ. Now we know from our previous videos on rates of reaction that the rate will increase with temperature. So if we look here, we can see at 40 degrees, 50 degrees and 60 degrees we form a cloudy suspension, and the cloudy suspension gets darker as the temperature increases. So we'll come back to this in just a moment. So a good place to start would be to look at the key points of this experiment. So to begin, you would get 10 centimeters cubed of hydrochloric acid, and you would add this to 100 centimeters cubed of sodium thiosulfate at a specific temperature. Then what you would do is you would place it on top of a red cross, and you would time how long it takes for the red cross to disappear using a stopwatch. You would repeat this process for the temperatures of 20 degrees, 30 degrees, 40 degrees, 50 degrees and 60 degrees. And you would record a results table that would have temperature, time and rate present. And from that you would then plot two graphs. Graph 1 would be the time taken versus the temperature, and the rate versus the temperature. So if we touch on this diagram here again, we can see that at 40 degrees, 50 degrees and 60 degrees, we can see that the suspension that is formed, which is of sulfur, when we react our sodium thiosulfate and our dilute hydrochloric acid, the suspension becomes much cloudier the higher the temperature. And also this reaction will happen quicker, so the X will disappear quicker at 60 degrees than at 40 degrees. Then below this here, I've put a sample of what a results table would look like for this experiment. So you can see that we have our temperatures all listed. The time in seconds will be gotten from our stopwatch, and you could calculate the rate by doing 1 over the time for each of our temperatures. Now, as I said, we would have two graphs for this experiment. The first graph would be time in seconds versus the temperature in degrees Celsius. And as we can see, the time decreases as the temperature increases. However, we want to check the relationship between the time and the temperature. So we must plot a second graph now of the rate versus the temperature. And as we can see here, as the temperature increases, the rate increases. But what is very important to note here is that we can see from this graph that the rate and the temperature are not directly proportional. And this is because the graph is not a straight line. So here's some sample questions that you could be asked on this experiment. The first one is, what is the variable used in this experiment? And the variable here is temperature. Next, they may ask why a dilute sodium thiosulfate solution is used. And the reason we use a dilute sodium thiosulfate solution is to prevent the reaction from happening too quickly at higher temperatures. Because if it's not dilute, the reaction will happen very quickly and we will be unable to get an accurate time from our stopwatch. The next question is to give two everyday examples of temperature affecting the rate of reaction. And there's multiple examples that you can give here. So for example, a fridge keeps food at cold temperatures, so that produces the rate of production of bacteria to keep your food fresh. And another one is catalytic converters in cars. When the catalytic converter heats up, it works better because the reaction between our harmful gases on our catalysts in our catalytic converter is quicker. The next question then is, why is the graph for temperature versus rate a curve where it's a linear graph for concentration versus rate? And this is because, as I said in the previous slide, temperature and the rate of reaction are not directly proportional. So it's key to understand that they are not directly proportional. The final question here is to name the gas given off when the sodium thiosulfate reacts with the hydrochloric acid in this experiment, and the answer to that question is sulfur dioxide. That's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.